Okay, to add and subtract rational expressions, we're going to be doing the same things that you would normally do with usual fractions. So just as a refresher, you need a common denominator before you can add. So what we do here is we think, what can 2 and 3 both go into? And we want the smallest thing they can both go into so it can make our life easier. If I think this needs to be a 6, well, I can times it by 3 to get 6, but I have to multiply by a 3 over 3 to make this a legal move. I'm actually multiplying by just 1. But this will make the fraction look like 3 over 6. Over here, to get it to be 6, it would be multiplying by 2 over 2. This again is a fancy 1, but when you multiply it would be 2 over 6. So these, if we simplified or reduced them, would be 1/2 and 1/3, but we scale them up so that we can add them. Now, if you have 3 out of 6 and 2 out of 6, that is 5 out of 6. Now, we don't always have to multiply both sides. Like in this case, we only have to multiply this by 2 over 2, and then we have 1/6 plus 2/6, which will end up with 3/6. So we don't always have to multiply. The idea here is that we want to do the least amount of scaling up so that we can add and have a common denominator. So you'll see this in calculus a lot. For example, you have to add these two rational expressions. To start off, like everything else in rational expressions, factor first. On the left side, I took the x out of the bottom there, and what I notice now is that both of these have x. The right side is missing this x minus 1. And so, to get it there, I can multiply by x minus 1 all over x minus 1. This right here is my fancy 1. Now, if you look at it, we have common denominators this way. And so, x minus 1 plus 3x minus 1 is what's going to be on the top of the entire fraction. And instead of writing these denominators twice, you can just write it as the common denominator. Now there's still some work to do, because I have to multiply in my 3. That'd be 3x minus 3. And still, it's all over x times x minus 1. And we should simplify this. So this would be 4x minus 4 all over x times x minus 1. Now, there might be some times where you have to check to make sure that in the end there's no simplifying that you can do further. And actually, in this case, there's more to do. You have to factor out a 4 on top. And then you'll see that it happens. We have a common factor here. My final answer, after simplifying it, is x. So in this case, this is my final example, but oftentimes you're just going to be here in the end. You know, for a lot of these, you add them together, and there is no simplifying, but once in a while you might have to. So just check. Check by factoring and seeing, is there anything that can cancel out? So here's another example. We're subtracting now, but the idea is the same. And we're thinking, well, this guy has an x plus 1, but the other fraction needs it. We only have x plus 4. I can't just subtract 3 from top and on bottom, which a lot of people want to do. What you're going to do is multiply by x plus 1 all over x plus 1. And then, likewise, x plus 4 is over here, but the other fraction doesn't have it. So you're going to have to multiply by x plus 4 all over x plus 4. Okay, now we have the same common denominator. Our denominator are these two things multiplied together. So on top here, I'm going to have 2 times x, 2 times 4, and I'll write that below here, 2x plus 8. Then I'll have, and this is where a lot of people make mistakes, we are subtracting, so think of it like a minus 3 times that times that. Minus 3x minus 3. And the common denominator now is x plus 4, x plus 1. Combine like terms on the top, you get minus x plus 5 all over x plus 4, x plus 1. And looking at that right there, you're not going to have any factors that cancel out. So you are done. As one last example, we're going to have a more complicated denominator. This denominator is going to be x times x minus 1. I pull out my GCF of x. On the other side, I again pull out my GCF of x, and it's x minus 7. So already we have something in common. We have this x involved. But the left side has x minus 1, the right side has x minus 7. So on this side, on the left, I'm going to have to multiply by x minus 7 all over x minus 7. And on the right side, I'm going to have to multiply by the missing part. Okay. And then we have our common denominators. Now I'm going to start expanding this and writing it as one fraction. I distribute my 5. Now up here, I'm actually going to have to FOIL this out. If I FOIL that out, if I expand it out, I get x squared minus 1, because that's the difference of squares. And then downstairs I have x, x minus 7, and x minus 1. So there's just a little simplifying I have to do on top. X squared plus 5x minus 36 all over x, x minus 7, x minus 1. And we do have to check, can we factor the top? Because sometimes you might have factors that can cancel. I'm looking at this, and I see that x minus 4 and x plus 5 would factor. But if you look at the factors here, there's nothing that's going to be actually canceling out. So you could just stop here, and you could say there is no more simplification.